to differentiate functional group and a homologous series. And when we are talking of the simplest homologous series, we talk of the alkanes. Alkanes. That's the simplest homologous series. Alkanes, right? So we are saying in alkanes, it contains carbon. This one, an alkane, it contains carbon and hydrogen atoms. It contains carbon, so we are saying carbon and hydrogen atoms. That is the simple homologous series. So we are saying the carbon atoms, they are actually bonded to each other with single bonds. So the carbon atom, they will be bonded together in single bonds to form a chain that can be straight, or the chain can be also branched. So we are saying the first number of the series is what? We can think of methane. Under alkanes, methane. I'm sure we have drawn the diagram for methane, CH4. So we are saying the second, so after methane, there is ethane. After methane, it has got two carbon atoms that are bonded to 6, right? So we are saying the functional group of the homologous is the what? Is the single bonds between the carbon atoms, right? So we also want to draw now these different functional groups, right? Starting with these alkanes, methane, ethane, right? So you see we get elements like hexane, right? Is we are saying we want to start dealing with what? These different homologous series, right? So we'll talk of alkenes. We'll start with alkanes, right? And then from alkanes, right, we'll draw the functional or the structure of the functional group, right? Alkanes, they end up with A, is the ending is A, N, E. For example, we can talk of methane or ethane, right? And then there is alkenes, they've got double bonds. There's alkalines, they've got triple bonds, right? And then we've got alkali halides, we've got alcohols, esters, ketones, aldehydes, carboxylic acids, esters, and arenes, right? So we want to deal with all these different homologous series.